Hello, this is RubyInsights, a channel dedicated to software engineering, architecture, best practices, and the tools that truly make a difference in professional development. If you are looking for technical clarity and a strategic vision of programming, subscribe to the channel and hit the bell to follow our upcoming content. RubyInsights, engineering beyond syntax. Let's get into today's video.
You are looking at a hyper-modern skyscraper swaying violently because its concrete foundation is cracking. This is exactly what happens when software engineering focuses entirely on high-level trends, like autonomous agents and solo developer deployments, while ignoring the structural integrity of the language itself. The mid-2026 Ruby ecosystem updates address this reality by starting at the absolute bottom of the stack, delivering mandatory security patches to the language core before introducing any new features. This diagram illustrates the getAtterInfo timeout handler, the site of a severe vulnerability patched in Ruby 4.0.5. As you can see, a memory block is allocated, but when the process halts unexpectedly, that block is erroneously freed. That creates a classic use-after-free bug. An attacker can forcefully inject a malicious external query into that newly emptied memory block. When the original process attempts to resume and reference the data it assumes is still there, it executes the attacker's payload instead. For legacy applications not yet on the Ruby 4 line, the core team released version 3.4.10. This provides a zero-friction update that bumps the bundled net-imap gem up to version 0.5.15, securing older architectures without breaking existing dependencies. With the language layer patched and secure, developers can safely move one step up the stack to the web framework layer, where the Rails team has been hunting down stubborn edge cases. You cannot build reliable software on top of vulnerable memory management. Securing the lowest level is the absolute prerequisite. A framework can only perform as well as the language beneath it. At the database layer, Active Record has historically been vulnerable to a specific resource exhaustion. If a user passes a massive, unvetted string of characters into an ID parameter, the toI coercion method attempts to parse the entire string, completely starving CPU resources. This formula, L equals S times 4, shows ActiveModel's new protection mechanism. A 4-byte integer strictly limits input to 16 bytes. Slicing the data stream here prevents endless CPU parsing, while standard routing patterns, like URL slugs, work exactly as they did before. Moving to concurrency, Rails developers frequently hit a persistent stale object error during file uploads. When multiple files hit active storage simultaneously, overlapping blob analysis processes would attempt to bump the record's lock version at the exact same time, causing the transaction to fail. To resolve this, Rails introduced the Preserve Lock Version on Touch block helper. It temporarily suppresses the lock version increment during blob analysis. The cache keys still invalidate properly, but simultaneous uploads can now process smoothly without tripping over each other's database locks. By patching these invisible bottlenecks, unbounded string parsing, and aggressive locking collisions, the framework now ensures that a sudden spike in traffic or data processing won't trigger silent catastrophic failures. Higher up at the application level, developers dealt with background video generation jobs hanging indefinitely. The culprit was FFmpeg, which would pause and wait for a manual keystroke, like Q, from a terminal that didn't actually exist in the background process. Rails now automatically intercepts those TTOU terminal signals during background execution. Video previews render to completion, and the job queue keeps moving without stalling out. Another major point of friction was noisy third-party dependencies flooding application logs. An otherwise stable app would generate massive walls of useless warning text, burying the actual data developers needed to see. This code snippet shows the solution: ActiveSupport.ProxyLogger. It wraps your primary logger and forwards the output, but maintains an independent severity level. You apply it to that chatty dependency, set the level to error, and the noise disappears, without having to monkey patch the entire application. Rails also refined database migrations, ensuring that add foreign key with the if not exists flag is fully reversible. When you roll back the database, it automatically generates a clean remove foreign key command that actually executes properly. When background jobs run smoothly, logs stay legible, and database rollbacks execute cleanly, developers stay in a state of flow. Eliminating these minor points of friction is just as important for maintaining engineering momentum as releasing major features. When we zoom out from the code base to the developers writing it, we find a community measuring its own evolution. The 2026 Planet Argonne Ruby on Rails Community Survey marks the 9th iteration of tracking these real-world development trends. This radar chart illustrates the primary objective of this year's survey, capturing the delta between theoretical AI tool hype and actual production workflow implementation. We are finally getting hard data on how teams are or aren't using AI agents day to day. Those emerging organizational trends are the focal point of Rails World 2026 in Austin, Texas. The speaker lineup reflects a shift in how engineering teams are actually being built and managed. For example, Arely Rivera's session details how non-technical designers are actively shipping production-ready code. By relying on explicit natural language contracts and shared CSS styling setups, designers bypass the traditional engineering handoff entirely. At the other end of the spectrum, Jason Sweat maps out modern solo developer architectures. He explains how a single engineer, leveraging strict automated testing and minimal feature scoping, can build and maintain systems as complex as a custom CI platform. By resolving these specific memory leaks, database overflows, and background hangs, the mid-2026 Ruby ecosystem removes the specialized technical debt that used to stall a release. It allows teams to stop debugging the plumbing and start focusing on the specific architectural patterns emerging in Austin this September.